stage, and for the before the opponent and the reviewer, please write down your name. Available. Opponent. Please write down your name. Available.
I can begin presenting now.
Okay.
Hello, my name is Thomas Lincoln, and I'll be presenting topic 13, charge meter for all-nighters. According to the problem statement, a lightweight ball is suspended from a thread in the area between two charge plates. If the ball is also charged, it will be deflected to one side at a certain angle. What is the accuracy of such a device for measuring the amount of charge on the ball? Optimize your device to measure the smallest possible charge on the ball. I'll be focusing on the behavior of the device as a pendulum and how it impacts the accuracy for measuring the charge on the ball. And I'll be looking at how the parameters should be optimized for accuracy. Here's a breakdown of my presentation. So first of all, to recreate this phenomenon, I set up two charge plates parallel to each other, one that is charged and one that's grounded. When the charge plate is given a charge, it causes a net induction on the grounded plate. And this causes the conducting ball in the middle to be deflected towards one side by polarization. Upon colliding with the charged plate, it receives a charge and be deflected towards the other side by the electrostatic force. Upon colliding with the grounded plate, it loses that charge and deflects back towards the opposite side by gravity and polarization. According to the topic statement, I have to give externally give an initial charge to the ball. In this situation, the first deflection will be by will be by electrostatic force instead of polarization, and during the first few oscillations, there would still be an initial charge on the ball. So, some observations I noted is, first of all, a high amount of voltage is needed for the phenomenon to work. And to do so, I will be using a windproof device, and I noticed some observations related to the machine. And I also noticed that a thread and a rigid rod can be interchangeable for attaching to the ball. I'll explain more on this later. And during the experiment, there is a visible electric discharge between the plates. So for this experimentation, here's the free body diagram and an additional diagram if I were to use a rod, and this is the diagram of the electric field. To model this phenomenon, I equated the rotational acceleration to the ball to the sum of torques on the ball, which is the electrostatic force on the weight of the ball. If I were to use a rod instead of a thread, I would also have to adjust the moment of inertia and add the weight of the rod. And here's a breakdown of all the variables I'll be using. So this is a diagram of my setup. I have two plates, one being grounded and the other one attached to one end of the wincher's device. The other end will be attached to a voltmeter that's being grounded. Between the two plates, I'll have a ball attached to a thread or a rigid rod. The opposite end of the thread or rod will be attached to the axis of a rotational sensor. The wincher's device will be turned by a motor, which I can grade the speed of with variable voltage supplier. And this is a photo of my setup. So earlier in my observations, I noted that there is a visible electric discharge between the plates. And using the known breakdown field of air and the estimated gap, I estimate the minimum amount of voltage needed to cause a discharge to be around 7,000 to 15,000 volts. The problem with this is that voltmeters typically do not go up to that high of a voltage. So to tackle this, I need to set up a voltage divider to reduce the amount of voltage to go to the voltmeter. Since my goal is to find the potential that the wincher is delivering to the plates, as long as I can find the ratio of the resistance in the voltage divider, I can find the true voltage without overloading the voltmeter. In a situation where I want to decrease the amount of voltage that is delivered to the plates, I would add additional resistors to both sides of the winchers of equal magnitude and leave them out of the calculation for ratio. And moving on to the data, here's a photo of the raw data I received from the sensors. And to find the charge, I will be numerically solving for charge by plugging the acceleration and voltage, and maximum acceleration at these points. At these points, the ball should be in contact with the ball and be at its maximum charge and closest to the charge plate. And for this calculation, I'll be taking an assumption of treating the device at a scale of capacitors. So I'll be taking some assumptions regarding the electric field, such as that it being a constant through the field, and it being perpendicular. So this graph shows the acceleration I received while varying the voltage. This is using a string and a 3.2 centimeter gap. And you'll notice, that the range of the voltage fits inside the estimated range that I estimated earlier. And this is a graph showing what would happen when I add those additional resistors to decrease the amount of voltage that I got. And so putting these together and putting these two data sets together and calculating the charge numerically, so do this by rearranging the model earlier, I can create this charge to find the charge on the ball that's delivered to the ball at these voltages. And you can see that the charge eventually decreases as I increase the voltage delivered for the as I increase the voltage on the plate until the charge reaches somewhere near the nanometer. And it also varies some additional parameters, such as the gauge that gap between the plates and replacing the third rod. Increasing the plate gap would not decrease the maximum static force, but it would allow the gravity to decelerate the ball enough so that it should increase the net acceleration. Switching the thread out with a rigid rod will increase the inertia of the system and should decrease acceleration. And this graph, where I vary the parameters, does support my theory. So moving on to the second part, the topic requires me that I actually add an external charge as well. To do this, I increase the gap between the plates and to turn off the wincher's machine, enough so that the ball does not deflect towards one side on its own. Instead, I hold it in place with a ruler and with a charged wire to deliver the charge to the ball. Upon letting go, it would have enough charge to be deflected towards one plate by the electrostatic force. This is the data that I received from the acceleration, and what you'll see is that the blue line represents the acceleration initially, and the purple line represents the acceleration a long time later. And what you see is that there doesn't seem to be much of a consistent difference between the two graphs, which means that the external charge I delivered to the ball would have dispersed quite quickly, only immediately after a few oscillations. There's only one oscillation on this graph that I can reasonably assume to be fully accurate for the external charge, which is the first oscillation over here. So in order to find more data points within a single experiment, I'll try to optimize the machine to give me more data points. But first of all, I tried to plug in that one data point that I received and was able to calculate that charge that I delivered to the ball to be around 90 nanometers. So earlier I stated that the externally given charge of the ball must have dispersed quickly. So what this means is that when I give a charge onto the ball, it would be deflected towards the plate with its opposite side. And upon colliding with that charge, it will lose that initial charge and receive some charge However, the charge on the ball at that moment would not be the regular amount of charge that it would have received as I calculated in part 1. And so it would take a few more oscillations before fully returning to that normal calculation that I estimated from part 1. So what this means is, so putting this together is that after several oscillations, you can see that the acceleration slowly increases until it reaches a normal amplitude. In order to add more data points, to utilize more data points with the experiment to calculate the charge on the ball, I can create a curve progression between the increasing amplitudes in order to estimate the charge. The orange line representing that first acceleration from downwards, so I can form that progression. So what this means is that I want more data points in order to better plot the trend line to estimate the charge. And it's also pretty reasonable to assume that there would be multiple oscillations. As I can remind you from the part 1, I calculated the charge that would be delivered by the plate around this voltage would be around 25 to 75 nanocoulombs, and I earlier mentioned that it would take around 90 nanocoulombs delivered to the charge. So that means that it would take at least a few oscillations in order to fully disperse that charge. So in order to optimize for more data points, I would increase the voltage delivered to the plates. So plates, as you can see here, this graph shows what is showing the high voltage delivered to the plates. And what you see is that it has little change to acceleration, meaning the charge delivered to the plate delivered to the ball is fairly small. And this can be shown by the fact that the ball has smaller contact time at high voltage. And this can be visibly seen. So if you do graphs at high voltage, the periods of the oscillations are much smaller, while the low voltage has periods longer. So in addition to ensuring that the voltage is pretty high, increasing the voltage, I also vary the inertia and the plate gap. And since I would minimize the inertia to increase the contact time, and also to increase the acceleration, and I would maximize the gap to decrease contact time, and also increase the acceleration, as shown by the graph that I found earlier. And a possible source of error is the fact that since my gap ranges around 4 centimeters to 3.2 centimeters, the position of the sensor would be there's not as much data points for the sensor to be precise. So increasing the plate gap would also allow more precision within the sensor. And in addition, it requires me to try to measure as small a charge as possible on the ball. So this requires me to at least make sure that the voltage is not too large, or at least too large to the point that there would be a visible discharge between the plates. And this will allow better measurement of small charge, and also make sure that the charge delivered by the plate wouldn't overwhelm the small charge. And there are some errors in my setup, such as how I deliver the charge, the stability of the plates, and the fact that I assume that the voltage on the two ends of the should be equal. So in conclusion, to optimize for measuring the externally given charge to the ball, I would increase the voltage delivered to the plate, but not too large so that it does not overwhelm a smaller charge calculation. And this is the summary of how I would optimize the remaining parameters of the force plate gap. Thank you.
Comments, please take the floor.
Okay, so first, what is the lightweight bulk made of? And
So
how do you reduce interference? For example, like electromagnetic interference.
can you clarify? And in what form?
The interference caused by elastic.
By the elastic collision with the plate? You mean how I want to reduce it?
Yeah.
I would first of all stabilize the plate so that it would fall as much, so that at least when collide with the plate, I would be able to have this capacity to be reduced and combined with the nuclear.
How do you measure your data?
So I have a rotation. Two sensors I use is a rotational sensor and a voltmeter. So I explain how I capture the voltmeter, and the rotational sensor looks like a wheel attached to an axis, and I directly attach the opposite end of the thread or rod to the axis of the wheel.
Do you think community will impact the result of the experiment?
Yes, it will impact the experiment, and which would increase the error of the two parameters not being correct, the equal voltage.
Okay, time stop.
So this is a common statement. For the pros and cons of the reporter, of course, he has a network with a chart. However, the number on the chart is too hard for us to see. Also, he has a lack of relation between the theory and the result. Okay, so he has the theory of electrician and the data analysis, which shows a linear relationship. So we can go to the discussion part. So first, you say more clearly about your conclusion.
So my final
Go to
conclusion.
the page.
Okay. So my final conclusion is that to better provide more data points for experiments about how to generate a regression to find the initial charge of the ball, I would increase the voltage. I would increase the voltage to the plates, although not too much, or else that would be not to the extent that would begin causing discharge, or else that would risk overwhelming a small amount of charge on the ball. And I also varied some other parameters. I also varied other parameters such as the plate gap and the inertia of the ball.
Okay, so first I want to ask about the voltage part. How I know. Then first, how do you make sure that the string won't influence the sensitivity of your experiment?
So I believe the string would influence the sensitivity in the same style of changing the moment of inertia. Increasing the moment of inertia would decrease the sensitivity. First of all, as I showed here, as I replace the string with a thread, replace the thread with a rigid bond, essentially the string much more heavier, it would cause the acceleration to be much lower and also increase the contact time, which is what I explained earlier, would reduce the amount of data points that would be offered to create a regression.
Okay, then back to the voltage. The windshield machine, you need to spin it to make the voltage, right?
Yes.
How do you make sure that you spin you spin the machine in a same velocity?
So I use a motor and attach it to a variable voltage supplier, and I vary the voltage by turning the voltage applied to the motor, and I can show that it's fairly consistent as. In this data over here, I can see that there's the data on the voltage is mostly consistent. It does oscillate a lot, but that's mostly machine issues within the windchers. And those peaks over there are what are shown to be the discharge between the plates, in which the voltage that a multimeter rendered would spike. But other than that, when the voltage is small enough that there won't be any discharge, you can expect the voltage to be fairly consistent.
You said in my last question, I asked you about the humidity. Then you said that humidity would influence the result. Then how do you reduce the impact of humidity?
First of all, I would move the setup towards a enclosed room and put a dehumidifier to decrease humidity. And in a situation where I couldn't do that, I would try my best to do all of the experiments at the same day, around the same time within one day, which is what I did. In most of the data sets where I compared to each other, I collected the data sets within the same day, or at least within, say, 2 hours. That changes in the climate of the thing would also impact the humidity.
Okay, then how do you make sure that the suspension of the ball is stable to minimize external disturbances?
Define some of the external disturbances.
Yeah, minimize external disturbances.
Okay, so some of the external disturbances I found is first of all the wobbling of the plates, which could impact the acceleration that's reflected back upon colliding with the plate. So of course, one thing I would do is to reduce the size of it, which is to stabilize the plate even more. But I already attempted to do so to the best of my ability. And yeah, that's one of my reduce the search.
Back to the current statement. It says that you need to optimize accuracy that you get. Then how did you define accuracy?
I would define accuracy to the amount of charge I would deliver it onto. So I would define accuracy by comparing how the charge calculated to the charge that I provided to the ball. How it's provided to the charge to the ball is also through a very large supplier, and I can try and looking at the voltage provided by the supplier, I can try to estimate the charge that's to the ball.
And how did you estimate how did you estimate? How do you estimate your expectation of the ball?
May I use the board? So, I would use the capacity, the equation for capacitance C equals Q over P, and define the PC of the ball, of a conducting ball. C of a conducting ball should basically be 4 pi multiplied by the permittivity of the air multiplied by the radius of the ball. And plugging this into C and multiplying it by V, which C multiplied by pi, it would be able to provide Q for what I would expect.
Okay, then I'll ask about the material of the plate. Do you think the material of the plate, how would it impact your experiment result?
If the plate was still a conducting plate, then I would expect, if you're saying that if I'm able to still use different material that's still a conductor, I don't think there would be much of an impact, except how fast the charge will be transferred over. So as long as I can still use the voltmeter to accurately measure the voltage that's delivered to the plate, I don't think it would have much of an impact by how much voltage I'm measuring. But as long as I can measure, so essentially, as long as I can still measure voltage and acceleration accurately, I don't think it would have much of an impact to how I do.
Then how about if I check the material of the ball? What do you think about that?
So would you change, like, what property of the ball would you change? What property of the ball would you want me to discuss? Like, or
maybe copper? If I change, if
Sorry?
I have a ball and I cover the ball with copper.
copper. That would, first of all, that would change the mass of the ball, so that's increasing the inertia, and also that would also change a bit of the capacitance of the equation. The change of material would cause there to be a slight area in between the ball, the lumen of the ball to be copper, and that would cause. And I can use rewrite the capacitance equation to change the ball of the capacitor, and that essentially that would affect the charge of the ball loop here.
So, is your ball, is it hollow or is it all with materials? Like, is it space in the middle of the ball?
There is a hole in the ball where I can thread the string through, but other than that, it's solid.
Then if the ball is only the outer, it's only the outer of the ball, the middle is there's nothing in the middle, then what do you think about that?
Assuming it has the same mass as the ball I have, but first of all, it would also increase the inertia, and it would also change the equation for the capacitance as there would now be an air. There is air now, assuming there's going to be air inside the ball, and that would change how you calculate the capacitance.
Then, suppose that if the ball is much heavier, then do you think the accuracy will be higher or lower?
I think it would be lower. It would impact the accuracy in the same style as the momentum, as switching out a thread with a rod, which would increase the momentum inertia. Increasing the momentum inertia would increase the acceleration and increase contact time, making it providing less data points and more likely to overwhelm a small charge.
If I have the same mass of the ball, and if the ball's volume increases, then how would it have an impact on the experiment?
First of all, it will also change capacitance, since capacitance relies on radius of the ball. And in addition, if I were to not increase assuming that I would keep the size of the gap the same, then it would increase precision as the area that the ball gets bounced into. The balls would become even smaller, and this would also increase the chance of discharge between the plates, as a smaller gap would allow a greater chance of discharge. And all of these would affect the accuracy.
One more parameter. It is about air resistance. Do you think air resistance would influence your experiment air resistance?
I don't think so. It's the size between the two, the area between the two plates is simply too small for an impact return. But if you were to make it bigger, it could potentially become an issue.
Okay. Then, Paul, question is about temperature. If the temperature is higher, do you think the angle of the ball will be, the accuracy for it will be easier?
The accuracy to measuring the angle with the charge.
Would be higher or lower? The accuracy.
Accuracy in measuring the angle or the charge?
Yeah, the charge.
Of the charge?
Yeah.
So first of all, I would think that increasing the temperature would be more likely to cause the electrons in the exposed metal to maybe cause more error with the electrons, the electron leakage.
And then there's uncertainty of your there will be uncertainty in your results. Did you consider uncertainty into your calculation of the accuracy?
So one uncertainty that I did mention is the difference is that I'll specifically move to my error slides. First of all, the slide where I have some where I have potential for error is first of all the method I deliver this charge onto the ball, which is I directly use my hand to pull the ruler, which would be prone to causing errors such as me accidentally pushing on the ball. I would probably reduce this by maybe building some sort of arm, non-conducting arm with the wire attached to it and simply just drop it. And simply use it to drop it, since it would actually require for me to retract the ruler quite fast in order to be put on the ruler. And another part for uncertainty is, of course, like assuming that the voltage on the two end temperatures.
Another question, the next question would be, how can you, if you have more experiments, how can you let the accuracy of your experiment improve? How would you improve your experiment accuracy?
Well, first of all, I would try to conduct the experiment. I would try to conduct the experiment with more voltages given to the plate as I try to deliver externally deliver this charge, as the optimum voltage delivered to the plate is limited by many factors such as the plate gap, the amount of charge I give off.
Time stop. Okay, so for our discussions, we talked about the material of the ball and humidity, whether humidity temperature would have some influence on the experiment result or not. Also, about the machine to make charge. We talked about how did he control the spinning speed of the machine. And also, we also talked about the material of the plate, whether how can the material of the plate influence the experiment, and also the volume and mass of the ball are equal.
Can you change to the compensation? What's the mass of the ball? Do you think it's a lightweight ball?
I think it could have been more lightweight, but I do consider it pretty lightweight for
Do you think it's a lightweight ball? Do you think 20 grams is lightweight ball?
Yeah, I think so.
The statement says that the ball should be deflected to one side at a certain angle, but in your experiment, it oscillates and What do you think about it?
I think in any situation where the ball would be able to touch the plate, it would begin to oscillate. And throughout all my observations, I was able to replicate a situation where the ball would be able to be suspended. To do so would either ensure a massive amount of voltage or increasing one of the parameters to a reasonable extent.
Okay, and did you take the outskirts of the ball insulation?
Have I ever insulated the ball? If you're asking that?
Yes.
No, but it would severely impact the nozzle if I were to shift out the insulators.
Do you think that you didn't let the outer of the ball insulated would affect it? Okay. And did you, because the plate isn't infinite big, so do you think it will increase the angle or decrease the angle?
So I think if you were to start the ball with an insulator, what would happen is that there would be a significant amount of charge on the ball would start interfering with the assumption that the fields are parallel and non-constant. I think it would start influencing the field lines moving and curving, and this would also increase the possibility of additional forces like polarization affecting the acceleration. So yes.
You think it will increase
Or decrease?
the angle?
I don't think it would decrease because polarization is an attractive force.
Decrease the angle. Do you think it will increase or decrease? Increase, okay. You mentioned that there's interference between the ball and the plate. One of it may be induced charge. What do you think it will increase or decrease?
I think first of all, earlier I mentioned how I would externally give it a charge and it would eventually be dispersed. If I were to also take into account the induction, then I think it would take longer for it to disperse.
reviewer.
This is a reviewer. At first, I want to talk about the review, the report. I think this is easy to understand, but the font is too small, and you have clear ideas, but you mentioned the theory limits small, and and you did the parameters that is faulted, but you didn't show the distance and angle between the plan, how it affects, and you explained the deviation, but you didn't compare the deviation and explain why. And for the opponent, we think your presenting style is clear, but it's not comprehensive. And I think you use too much questions that are not important for this statement. And you didn't organize it well. You just keep taking out the questions. And for the key discussion, the first opponents asked about how the string. They think it will decrease the sensitivity. The reporter thinks that the string will increase the moment of inertia and it will improve it. But we think it's not the. We think the conductivity of the string is important because it's related to the charge. Maybe the charge will go back up and it will be grounded. And it will be grounded. And the opponent says humidity is to be concerned, and the reporter says it will change much within a day. But we think that the humidity is important because it will influence the dielectric constant of the material. So it should have been controlled. And the opponent thinks the temperature it should be conserved. And the reporter thinks it will excite the electrons and decrease, but we think it's not high enough to influence it. And our question, we asked the reviewer, we were asking you about the problem statement about lightweight. We think you all think it's light, but we think it's not because compared to the charge is very small, so we think it should be lighter. And then it's a ball isolated bit effect. The reporter didn't do the acceleration, and opponent thinks it was an effect. We agree it's because the charge of the ball will touch the plate, and the charge will go through. Yes. And it's an infinite plate effect. They all think decrease, but we think it will increase because from Laplace's equation, the middle of the middle electric field will be bigger if it's not infinite. Okay, and I think it's okay.
So I'll now give some final remarks on my report. First of all, the opponent reviewed briefing of the conductivity of the string, but I agree that it does have an impact through its conductivity, but I think it's still negligible, and most of its impact will still come from its inertia. And I also agree that humidity will have an impact, and I did adjust this by saying that I conduct the experiments as close as in a small time period as possible. And I also attempted to reduce the experimental error due to energy loss by stabilizing the metal plates. And I also used the summary of my theory is that I used my model to predict the amount of charge on the ball by knowing the change in the charge on the ball by the plate, and fitting regression from the steady state to the charge. And I focused on reducing error by decreasing the contact time, which would decrease the rate at which the ball will reach its steady state, and it will also provide more data points to find a better fit. And while I think the material will, I think the material that will affect the capacity of the plates, I think the measurement, as long as it would not impact the measured, it would not impact the measured charges. And I think the material could change the rate at which the energy is lost, but that depends on conductivity. And while the problem while the problem does state that the ball should be deflected towards one side, And as I replicate the phenomenon, it begins to oscillate. So that's why I decided to go further down into exploring this phenomenon. And well, I think the installation will decrease the angle in respect to the horizontal due to greater distance of charge and greater polarization. I think that the greater impact will be decreasing the angular acceleration, which will not be possible.
Okay, so could you turn to the problem statement, please? The problem statement. Page 2. It says measure the amount of charge on the ball, right?
Yes.
Your method by itself, doing the charging discharging, you will constantly change the amount of charge on the ball. So you introduce a big uncertainty or unknown on the amount of charge on the ball. So how can you measure the smallest possible charge on the ball?
So first of all, most of my exploration within my report is looking at the behavior of the device. So as long as
I'm sorry, you see that?
Please speak slow.
I've been exploring the behavior of the device and looking at how much charge the plate delivers to the ball, and I've been offering solutions so that you can better optimize finding the difference between the initial charge and the charge delivered by the plate.
No, it says, tell us the amount of charge on the ball, right?
And so,
So where is your answer to that?
I wasn't able to find the smallest possible charge since there was a lot of parameters needed to intersect when it comes to decreasing the amount of charges that you take between the
Would it
behavior.
be possible that your method doesn't work for this problem?
I mean like physically achieving delivering the smallest possible charge. Well, I would also have to intersect between many parameters such as the distance to the plate, the charge delivered to the plate, and the parameters have to fit together. And in the which I got and the plate that I got, so I would be able to minimize the charge as much. So one way I would have minimized it even
Okay,
more.
thank you. So for the opponent, you have a, I don't know, should I call it better method to do this problem, to solve this problem?
To save some time.
Okay, sure.
So can you answer the setup for the reporter is right or not?
I think it could minimize the accuracy.
Okay, so for the reviewer, no, please say why.
We think, in our opinion, to this statement, it has to mention the amount of the ball, but they didn't. It won't be a certain amount because it's
Okay, so let me ask one more question. Should the ball contact the plate for the reporter?
So the phenomenon that I replicate, it would
Yes or no?
should it collide with the plate?
Yeah,
Preferably not.
no. Okay, so
Do we think?
just yes or no?
No.
No. No. Okay, so if we go to the problem, so what is the most important parameter for this experiment? How do you check the accuracy?
The voltage on the plate and the mass of the ball.
Sorry?
The voltage on the plate and the mass of the ball.
Yes, and then for you,
I think it's the voltage.
voltage for the
Uncertainty.
yeah. So what is the most important parameter?
we think is the potential difference between the two.
Is there any other questions? Okay. So now, for the reporter is 3, 4, 6, 5, 4. And for the opponent, it's 4, 4, 4, 4, 4. Okay. And for the reviewer, 4, 5, 5, 4, 5.
6.
Sorry, 6. Sorry. So, anyone like to give some comment? So, yeah, please.
I think I almost always have the same question as Professor Man. Because I think in the case of reporter, I think the equipment and the setup do not match the problem very well. It's asked the angle, the TO angle, and the relation to the amount of charge. But I do not see any relation between the angle and the charge. Also, the computation of the equations do not well explain. However, the opponent and the reviewer do not really ask these most important points. They do not ask anything about equations. But you know the reporter speak that part very quickly and do not well explain. But no one asks that, and no one asks the setup will match the problem or not. So I think it's not good performance or report about this. Yeah.
Professor.
Professor.
Okay, so I have a small suggestion that you should really understand what the problem is and what it is asking you and what is the most important parameters. Okay, so let's thank you for your